Hi everyone, this is Biddeford High School Graduation Standard A4.2, Systems of Equations, Level 3 Notes. So let's take a look at the learning target. Our learning target for this level of the standard, you will be able to solve a 3-variable system. Of course with these notes and a little bit of practice. So up to this point, we have been dealing with 2-variable systems. So 2 variables, 2 equations. Now we are dealing with 3-variable systems. So 3 variables and 3 equations. Okay, and as we've discussed up to this point so far, this should be a review from Algebra 1. So standard A4.1, solving a 3-variable system, is the level 4. For A4.2, solving a 3-variable system, obviously, is the level 3. So, as we've discussed, the only difference between standard A4.1 and A4.2 is that the 3-variable system in A4.1 is the level 4, and in A4.2 it is the level 3, and we will deal with linear programming and nonlinear systems in level 4. Alright, so let's get started. Let me scroll down a little here. Okay, so solving systems of equations with 3 variables. At this time, we already know how to solve for systems of equations with 2 variables using graphing, substitution, elimination, and everyone's favorite, Cramer's rule. So far. So we've taken all 4 of these strategies and solved 2-variable systems. Okay? So I think the best way to solve 3-variable systems is to work through an example, because really we're not doing anything new. Okay? So do we know how to graph this problem? No. In fact, this would need to be graphed in 3 dimensions. Okay, so we're not going to graph this. That is not ideal for us right now. Could we use the substitution method to solve this problem? Yeah, well, I'm sure we could. But it would get a little bit too complicated. So let's just say but it would not be ideal. There must be an easier way. Okay, give you a second to write this down. Pause the video if you need some extra time. Okay, so think about Cramer's rule. How do we find the determinant of a 3 by 3 matrix? At this point, we don't know. There is a way but we will not discuss it in this class. So it turns out, as we know, finding the determinant of a 2x2 matrix isn't that complicated. Finding the determinant of a 3x3 matrix, it's a little more complicated. I'm sure you could wrap your mind around the mathematics at this point. 4x4 matrix just gets way more complicated. Okay, so at this point, we don't know how to find the determinant of a 3x3 matrix, and we're not going to find out, unfortunately, in this class, unless we have some extra time. Okay, so because of how difficult and challenging it will be to use graphing, substitution, and Cramer's rule, we will use the elimination method. To solve systems of equations with 3 variables. Great. Pause the video if you need a little bit more time. Okay, so back to our problem. First, we will eliminate one of our variables using 2 of the equations. Okay, so it's nothing different there. So we're going to pick 2 equations and try to eliminate one of our variables. So looking at this system up here, the easiest variable to eliminate will be t using the first 2 equations. And of course, that's because we don't have to scale either equation. Okay, so let's do the math here. Draw my line. Let's combine all our terms. So, right off the bat, positive 2t and negative 2t, they cancel right out. 5r minus r, of course, is 4r. 5s plus 5s is a positive 10s. Of course, we have that canceled, and 13 plus 9 is 22. Okay, so for right now on your paper, I would star this equation. Keep it handy, we're going to need it soon. Okay, so now in order to solve a system of equations with 2 variables, we need to eliminate t again using two different equations. So we took 2 equations up here, eliminated a variable. So now what we want to do is create another equation similar to this, a 2-variable equation with r and s as our variables. So we're going to do that by eliminating t again using 2 different equations. Okay? And does it matter which equations we use to do this? No, it doesn't. And why is that? Because we are dealing with a system of equations, of course. Give you a quick second to write this down. If I'm going too fast, feel free to pause the video. Great, let's scroll down here. Okay, so for this example, again, you could pick two other equations, doesn't matter which two. Okay, let's use equation 2 and equation 3. Great, awesome. You could also use 1 and 3 if you really wanted to. Okay. So, looking at this right here, we're trying to eliminate t. So we have a positive 6t down here and a negative 2t up here. So we can multiply this negative 2t by something to get to negative 6t. And if we had negative 6t, it would cancel out with this positive 6t. Okay, so we can eliminate t by multiplying the top equation by 3. Okay, and if you can't see that quite yet, don't worry, we'll go over that right now. Okay, so what I'm going to do down here, just put the two equations down here. I'm going to put parentheses around this top one. Okay, and I can eliminate t by multiplying the top equation by 3. So let me put my 3 here. I'll put my new equation down underneath, drop it right underneath. Okay, so 3 times negative r is negative 3r. 3 times 5s is a positive 15s. 3 times negative 2t is negative 6t. And 3 times 9, of course, is 27. So there, I've scaled my equation. So let's combine these. So I have positive 6t right here, negative 6t right here. Those are going to cancel. I have 2r minus 3r, which is negative r. Negative 2s plus 15s, which is a positive 13s. Of course, our 6t's cancel, and we have 14 plus 27, which is 41. So I'll start this equation as well. Okay. Remember, we start our first one as well, way up top. Our second equation we're going to use just shortly here. So now we have another equation where t has been eliminated. Because we now have two new equations, we can solve for r or s. Okay. So we took our 3 variable equations, and from those 3 equations found 2 new equations where 1 variable was eliminated, in this example t, and now we have 2 new equations, both 2 variable, which we know how to solve, in terms of r and s. Great. So let's scroll down a little bit. Alright, so I'm going to write those two equations that I started down right underneath here. Okay, so I have negative r plus 13s equals 41. And then my second equation is 4r plus 10s equals 22. Okay, two new equations. So we know how to solve systems like this. I'm going to use the elimination method. Okay, so let me change my color here. Let's go to orange. Great. So I'll draw my line. Actually, before we even do that, we need to figure out a variable we're going to eliminate. Okay, so looking at this, we have our choices of r and s. Well, s is multiplied by 13 up here and has a coefficient of 10 down here. So in this case, we'd have to scale both equations. So I don't want to do that. So let's look at the r's. So I have a positive 4r down here and a negative r up top here. So if this top equation, if this r had a coefficient of negative 4, I would have negative 4r plus 4r. Those would cancel out. So what I'm going to do, I'm going to multiply this top equation by 4. I'll bring it right down underneath there. So 4 times negative r is negative 4r. 4 times 13 is a positive 52. Of course, I have my s. And 4 times 41 equals 164. Okay, so now I'm going to combine. So 4r minus 4r, that cancels. 10s plus 52s would be 62s. And 22 plus 164 would be 186. So if I divide 62 from both sides to get s by itself, we can see that s equals 3. Great, awesome. So let me switch back to purple here. So knowing that s equals 3, we can plug in 3 for s into one of our two equations in order to solve for r. So just to break that down a little bit, we know that s equals 3. We found that up here. So now we can plug in 3 for s, since s equals 3, into one of our two equations. And by the two equations, we mean these ones in purple up here, the ones we found. Okay? Because since those are equations with two variables, if we plug in one of the variables, we'll just be solving a one variable equation. Okay? So since we know what s is, we can plug in 3 for s into either this equation or that equation, and we'll be able to solve for r. Okay? So let's say this bottom equation right here. So I have 4r plus 10s, but instead of s, I'll plug in this 3 right here, equals 22. So just to simplify, I have 4r plus 30 equals 22. Subtract 30 on both sides. I get 4r equals negative 8, which leaves me with r equaling negative 2. Awesome. I'll give you a second to write that down. Again, pause the video if you're running behind. Okay, so at this point, we know what two of our variables are. So we know that s equals 3 and r equals -2. Okay, so what do we do next? Have two variables, need our third variable, which would be t. Okay, so we can plug in (3 and -2) for s and r, respectively. Using one of our original three equations. So way back at the beginning, we were given a three-variable system with three equations. So since we have three variables and we've solved for two of our variables by breaking it down into a two-variable system, we can take these two variables and plug them into any one of our three original equations, and we will be able to solve for t. At this point, it doesn't matter which equation we use, as long as we plug in s equals 3 and r equals -2, we will get the same answer for t, because this is a system of equations. Okay, so which one am I plugging into here? I'm going to do the top one, predetermined. So I have 5, -2, this was an r previously, plus 5s, but instead of s, of course, I'm going to plug in the 3 up here, plus 2t equals 13. Okay, so I'm going to simplify. -10 plus 15 plus 2t equals 13. So simplifying a little bit more, I have 5 plus 2t equals 13. So if I subtract 5 on this side, that'll cancel that 5 out. Subtract 5 on this side, I'm left with 2t equals 8. So from that, I know t equals 4. So I'll circle that answer. My s equals 3 down here, and my r equals -2. And more often than not, let me go over here, you'll see the answers written in brackets just like this, in order. -2, 3, 4. That's good too. Awesome, great. So we'll finish off these notes for the time being with this last example here. Oops. Okay, let me try this in red. So what I'm going to do, first step, I need to pick two equations to cancel or eliminate a variable. So if we look up here, we look at the first equation, we have negative 5x plus y minus 5z equals 23. And the second one we have negative 2x plus y minus z equals 3. Well, I have a y right here, positive y, and a positive y right here. If one of those y's were negative, I would be able to eliminate the y's. Great, so let me rewrite the top two equations. In my second one, I have negative 2x plus y minus z equals 3. So, what I'm going to do is multiply this top equation by negative 1 to change the sign of that y right there. So we'll bring it down here. We have negative 1 times negative 5x, which is a positive 5x. Negative 1 times y, which is a negative y. Negative 1 times negative 5z is a positive 5z. And negative 1 times 23 is negative 23. So, doing some arithmetic here, y's cancel. That's our goal. Negative 2x plus 5x would be 3x. Negative z plus 5z is a positive 4z. And 3 minus 23 is negative 20. So remember, let's star this equation. So now what we need to do is pick two other equations up here and eliminate the same variable. So we eliminated y, we need to eliminate y again in order to get a two-variable equation in terms of x and z. So, how about at this point we take the second one here and the third one. So let me rewrite these. I have negative 2x plus y minus z equals 3, and negative x minus 5y plus 2z equals 0. So I have a negative 5y down here. So I'm going to multiply this top equation right here by 5. That would get me a positive 5y right here, and I'd be able to cancel or eliminate those y's. So parentheses, my 5 right there, and I'll move it right down here. So 5 times negative 2x is negative 10x. 5 times y, as we just discussed, is 5y. And 5 times negative z is negative 5z equals 5 times 3, which is 15. Okay, so negative 5y plus 5y, that's gone. Negative x minus 10x is negative 11x. 2z minus 5z is negative 3z. And 0 plus 15 is 15. So I'll star this equation as well. Great. So let's go up here. So I'm going to take my starred equations right now and try to solve for one of my variables. Again, I'm going to use elimination. Okay, so let me change color. So I have 3x plus 4z equals negative 20. And I have negative 11x minus 3z equals 15. So let's take a look here. Again, it doesn't matter which variable we try to eliminate, just as long as we eliminate a variable. So, looking at this, I'm going to choose z. And there's not one equation I can scale. I have to scale both equations. Okay, so what I'll do, 4 and 3 are both factors of 12, so I'll multiply this top equation by 3 and this bottom equation by 4. I'll put them right over here. Okay, so 3 times 3x, that's 9x. 3 times 4z, that's 12z. And 3 times negative 20 would be negative 60. And the bottom one, 4 times negative 11x, is negative 44x. 4 times negative 3z is negative 12z. And 4 times 15 is positive 60. Great, so I have positive 12z minus 12z. Those will cancel. I have 9x minus 44x, which turns out to be negative 35x. And negative 60 plus 60. Well, of course, that's 0. So if I want to solve for x, I divide by negative 35 on both sides. I get x equals 0. Awesome. One variable down, 2 to go. Okay, so what I'm going to do with this x, it's no different from the two variable systems. I have this one variable x, it equals 0. I'm going to go back to my two start equations, right here, and they're both up here. And I'll plug in x, or plug in 0 for x. So let's do this bottom one right here, the negative 11x minus 3z equals 15. Draw a little arrow. So I have negative 11, instead of x I'm putting 0, minus 3z equals 15. Okay. Well, negative 11 times 0 is 0, so I'm left with negative 3z equals 15. Of course, I divide by negative 3 on both sides. I get z equals negative 5. Great. So now I have x equals 0, z equals negative 5. Still need to find y. So our notes tell us that we go right back to our original 3-variable system. We have 2 variables, so it doesn't matter which equation we use. We'll plug in x equals 0 and z equals negative 5. Again, doesn't matter which equation we use, and we can solve for y. So let's do the second one right here. So I have negative, actually, let me specify. So I have negative 2, instead of x I'm putting 0, plus y, minus negative 5 equals 3. So negative 2 times 0 is 0. I'm left with y minus negative 5, turns into a plus 5, equals 3. So subtract 5 on both sides, get y equals negative 2. So, again, as I said earlier, we can write our answers just like this. X is 0, y is -2, and z is -5.